Swayam Prabha. Digital India. Educated India.
Welcome back to the course Geology and Soil Mechanics. So, as we decided in the last lecture that we will be solving few problems on permeability in soil. So, the first problem that is the problem number 9. It says that a falling head permeability test was carried out on a 15 centimeter long sample of silty clay. The diameter of the sample and the standpipe were 9.8 centimeter and 0.75 centimeter respectively. The water level in the standpipe was observed to fall from 60 centimeter to 45 centimeter in 12 minutes. Determine the following. First one, the coefficient of permeability of the soil, height of water level in the standpipe after another 20 minutes, and time required for the water level to drop to 10 centimeter. So, this problem is basically based on the theory which we have covered in falling head permeability laboratory test. So, let us solve this problem. So, we will go to the problem directly. So, this is your problem 9. Now, for a falling head permeability test, we have. So, this we know from our theory whatever we have covered in the lecture, that is K, that is the coefficient of permeability or the hydraulic conductivity, that is expressed as A into L. What is A? A is the area, cross sectional area of the standpipe, L is the sample length, divided by capital A into T, where capital A is the cross sectional area of the soil sample, soil specimen, and T is the time into log base E H1 by H2. That is the, whereas H1 is the initial head and the H2 is the final head, and that basically this expression is known to us, and we have derived this expression and we have seen how we have got this expression. So, there is no issue, we will not further discuss about this equation. So, here in this problem, your A, that is the cross sectional area of the standpipe, can be obtained as pi by 4 into 0.75 whole square, where 0.75 centimeter is nothing but the diameter of the standpipe as given in the problem. So, that comes as, so I will keep that thing as it is. So, because I do not need to calculate this thing, you will see that why. Well, so capital A, that is the cross sectional area of the soil specimen, that comes as 9.8 whole square, where 9.8 centimeter is nothing but the diameter of the soil specimen. Okay. Now, what is the L? Length of the soil specimen that is given in the problem, that is 15 centimeter, and T, that is given in 12 minutes, right, because it takes 12 minutes from 60 centimeter head to 45 centimeter head. So, that comes as 720 seconds, okay, in terms of second. H1, that is the initial head, okay, from where you are starting or you are initiating the experiment. So, that is given as 60 centimeter, and what is the final head you have observed after 12 minutes, that is 45 centimeter. So, these are the parameters are given in the problem. So, now we will calculate K as pi by 4 into 0.75 whole square, that gives us small a into 15, that is L, divided by capital A, pi by 4 into 9.8 square into 720 ln 60 by 45. So, we did not calculate the area because we will take the advantage over here. So, they will get cancelled. So, ultimately I will get 3.51 into 10 to the power minus 5 centimeter per second. So, this is your coefficient of permeability or the Hartley conductivity, right. So, as you have seen, so basically I mean this expression was known to you. Now, basically whatever parameters are given in the problem, based on that you have calculated all the things and your permeability is coming 3.51 10 to the power minus 5, and that will be remaining same for the rest of the test. I mean whatever you do the test, because permeability will not be changing as long as you are considering the same soil sample with same void ratio, same constitutions and same say your structural behavior and all those things will be remaining same. So, this permeability will be used for rest of the problem. Now, in the second part, so it is asked that the height of water level in the standpipe after another 20 minutes. That means, you have waited till 12 minutes. So, head was falling from 60 centimeter to 45 centimeter, and then we are considering another 20 minutes, and then we want to find out that how much will be the head. Okay. So, in the standpipe. So, let small h be the head at the end of another 20 minutes. Okay. So, therefore, in the previous expression, now you have got the coefficient of permeability. So, that is not unknown to me. So, 3.51 10 to the power minus 5 is equal to pi by 4 into 0.75 whole square into 15. The sample is remaining same. So, the length of the sample will be 15 centimeter divided by pi by 4, 9.8 square, another 20 minutes, right. So, that means I am expressing that thing in terms of second. So, 20 into 60 log base E. Now, from this is 45 is your initial head. Now, because you have allowed the water to fall from 60 to 45 centimeter, and then you are starting the experiment for another 20 minutes. So, that means your initial head will be your 45. So, 45 will be coming as H1, and this is your final head after 20 minutes, okay, for another 20 minutes. So, from this if you solve, you will be getting H equal to 27.86 centimeter. Okay. So, this is the final head after another 20 minutes of the test. Now, we will go to the third part. The third part says it is asking that the time required for the water level to drop to 10 centimeter. That means, you are say suppose you are starting from 45 say centimeter, that is your initial height say in the standpipe. Now, you are allowing the water level to fall in the standpipe to fall